Hello everyone and welcome to this next lecture on data visualization with Python. So in today's topic, we will be talking about pandas and how to do data visualization using pandas itself. So we have seen matplotlib, we have seen seaborn, few of the Python libraries for data visualization. But now I want to talk about pandas and what are the capabilities that pandas has in built in for data visualization. Okay, so as you have seen, like we need to import matplotlib and we need to import seaborn and use all the functionalities, all the functions, all the properties of those two libraries in order to visualize any kind of data that we want. But there is a very handy and very useful part or useful proper properties which is built in pandas for data visualization. So today I would like to talk about that. Okay, so we'll start by importing NumPy and Pandas. We NumPy because we'll be needing some data. We need to work with some numerical data, and Pandas because of course we are talking about the Pandas data visualization capabilities. Okay, and the data that we're working with is randomly generated and data. So this data is just for example, and we will look at like it's a very simple data, right? So I have three CSV files just like this df1, it has like normal data, right? And df2, it has like four columns and some randomly generated data in it. Then we have df3, like this abcd, four columns and randomly generated data, right? So we'll be using these data to work with pandas built-in data visualization, right? So first of all, we in df1 we are saving, we are reading the csv df1, and we are doing this index column is equal to 0. That means the index names I want are the column number 0. So like in the first column is the index of my data frame that I want to create. So basically if you see the head of this data set, the first column is this date, right? And I want the dates as the row names or the indexes. That's why I use this argument index column is equal to 0. And in df2 variable, which is a data pandas data frame, I'm just directly reading the df2 without this index column parameter. So like the only point here is if the first column in your csv file belongs to the row names or are the indexes of your data set, then you have to put this thing as you have to identify that column here in the index column argument. Okay, so this is my df1, this is how my df1 looks like. Now we will be working with these two data frames, right? So there are something called style sheets, which style sheets are like a proper format or a design format which you want to give your plot to, right? So suppose you want all your plots to follow a typical structure or typical design, then you can give them all of them a style sheet. Okay, so here is a link which you can go ahead and look, right? So this is the all the style sheet that you can use: plot bmh, plot dark background, plot 538, or plot ggplot, right? So these are different style sheets or like the design formats which all the plots should follow. So I highly recommend to use these uh, style sheets in your plots. Okay, so suppose I want to plot the histogram of this particular column, the column A of df1 data frame. So I can directly plot the histogram just by using df1 column A hist dot histogram, like after the column one. So df1, and I'm using indexing to fetch the column A, and I'm just doing dot hist, and it is giving me a histogram like this. Okay, so there is no need to import matplotlib or use seaborn. Just directly the column, first you do indexing, you reach to that column and do dot hist to get a histogram. So this is what my data looks like, right? I can also pass different properties, like if you want to have some bins, then you can give bins to be maybe like 30. Okay, so like here it is, right? The bins are 30. It became red because like I'm using a different style sheet. Previously it was blue, right? So now I want to use this style sheet called ggplot2, right? So import matplotlib pyplot as plt. And why I'm importing this? Because I want to use the style sheet. So the style sheet or the style use property is a function, is a part of the matplotlib.pyplot function. Okay, so I can use plt.style.use ggplot. Right, I can use any style that I want, so I can see all my graphs in a particular format, design format. So if I now plot the histogram for the a column of data frame 1 df1, it looks like this. Right, if I use plt style sheet dot use bmh, and if I plot the histogram of the same column, now it will look like this. Okay, blue color with the grid in the background. Or if I want to use plt.style.use dark background and I plot a histogram of the same thing, it will look in this way. Right, right. It's a dark background with a lighter foreground. Okay, or I can use the style sheet as 538, plt.style.use 538. Then if I plot the same column, it will look like this. Okay, so all these the my names or my tick marks, x-axis and y-axis is in white color, so like it is very rarely visible, but the styles are there and there is no closing of the grid. Okay, so you can explore all the different style sheets that you want to use. You can just click maybe like, so plot dark background. If you use this slide, this style sheet, you can use like this. Okay, you can go through it and have a look what style sheet serves your purpose. You can use that style sheet. There's a lot of list of style sheets to be used. Okay, now so for our plots, we are using this ggplot for our further plots, right? And now we'll be looking at all the different kind of plots which comes built in with the pandas library. So it gives you, it saves a lot of your time, and you need not to have the knowledge of other plotting libraries like Seaborn and Matplotlib, and it's very handy when you are just exploring your data set, when you are just exploring or figuring out what your data is all about, and you can just directly plot using pandas, right? So now next plot is the area plot. So I want to plot for df2 plot area, and I can plot a area plot like this. It's an area plot. Here the alpha correspond, the alpha parameter is the transparency. If I increase this, my plot will become more trans. So the higher the value, the less the transparency. If I make it 1, it is like there is no transparency, right? If I make it 0.1, it becomes highly transparent. See, the plot is there, but you can see through the plot. So if I make it zero point 0.3, it's a bit darker, right? There is a, so alpha value gives you transparency, and df2. So remember what is df2? df2 is this. So if you want to see what is df2, so let me just do df2 dot head. This is what df2 is. It has 4 columns abcd, and when you're doing a area plot, so it is plotting all the values of these 4 columns, right? So like all these different colors correspond to the 4 columns, and it shows the values that each of the column is taking. Okay, now next is the bar plot. So how can you, so this is what df2 looks like. You want to have a bar plot, I can do df2 data frame dot plot dot which plot you want, bar plot. It will give you a plot like this. Okay, so it is plotting for all the rows, it is plotting all the 4 columns, right? So for each row it is plotting abcd, second row abcd, third row abcd, right? Like this it is plotting for all the columns. Let's plot df2. So df2 has 10 rows only. That's why I get 10 plots here from 0 to 9. Okay, but see, if it is, if you think it is a bit congested and it is not clear, then you can use this parameter stacked is equal to true. There, then you can have a plot like this where all the four of the values of all the 4 variables or all the 4 features is stacked on top of each other. So like for each row, the values of abcd column is being given in this way, stacked on top of each other. So red one is the A value of the A column, B blue one is the value of B column, purple one is the value of C column, and the gray one is the value of D column. You get a legend by default here, right? So then you have to plot histogram. You can plot histogram by calling a column, right? So df1 and use indexing to reach to column A, then plot dot histogram, or directly you can use histogram, right? And you can pass all the parameters that we have used with the histograms. Right, now let's look at df1, right? So this is my df1, and df1 is has 1000 rows and 4 columns, right? Now I want to plot a line plot. Suppose for df1 dot plot dot line, and my x should be a and my y should be b. So I'm plotting a line plot between a and b, right? So so line plot will connect all the dots for like there are 1,000 points, and it will connect all the points starting to the end. So I will get a plot like this. I can provide all the parameters like figure size, line width, whatever we have seen in matplotlib lecture. All the parameters we can pass in here. Hey, this is a plot. This is how my plot looks like, right? Suppose I want to have a scatter plot, then I can just do df1 plot scatter. X should be a, y should be b. So I want a scatter plot between the column a and column b. Then I can just directly plot using pandas like this. Like in just one line I can have a plot. So it looks like this. I can change the figure size by providing the fixed size and pass as a tuple, right? Or I can also pass different color parameters as we used to do in matplotlib. So you can, there's a reference, you can choose color maps from here, right? All the color maps that you were able to use in matplotlib, you can use it here too, right? Now suppose I want to have a scatter plot, df1 dot plot dot scatter, x should be column a, y should be column b, and c, what the color should be the column c, right? So basically I'm trying to represent three things in this 2D graph. So the x-axis gives me the value of the column a, the y-axis gives me the value of column b, and the color gives me the value of column c, right? And the c map is magma. I can use any other, or you can use any other color as per your requirement, right? We can also add a fourth dimension to this plot by using the size parameter or the s parameter, right? Suppose I want to, so like in this plot I want to give information of the fourth. Well, I want to add one more information, right? How can I do that? Let me just zoom out a bit. Yeah. So suppose I want to add one more one more piece of information to this plot. So this plot is currently, if you take any point, so that particular, the x column will give you the value, the x value of that, but the x coordinate of of that particular data point gives you the value of column A. The y component or y coordinate of that particular data point gives you the value of the column B for that particular data point, or the feature B, right? And the color gives you the value of the column C, right? And the size of that particular circle gives you the value of column D. This is how we have done it. Let me increase the size, right? So df1 plot scatter, x should be a, y should be b column, the size should be the df1 the c column into 100. Why we have done this 100? Just to increase, because if you don't do this, let me remove this. If I again plot this, all of the points are very very small. See, these points are very small. Just to scale the size by the constant factor, we have made the size to be 100. Now see it, all of them are visible. So basically, the size of the circle or the size of the each data point is corresponds to the C column, 100 times the C column. So this is the size, and color is the D column, and the color map that we're using is magma, right? This is pretty good. So I have captured all the information in just this 2D graph, right? You can do a box plot by using df2.plot.box, right? You can also pass by argument if you want to do a group by any column, right? If you want to do a hexagonal bin plot, you can do data. Let's create a random data frame first. So df is equal to pd dot data frame np dot random dot rand n. So give me random numbers, 1,000 rows and 2 columns. So I want random numbers from the normal distribution in this shape. So the shape is 1,000 rows and 2 columns, and the column names are A and B. So this is my data. This is what my data looks like. Now I want to plot a hexagonal bin plot. So how can I do? I can do like df dot plot dot hexabin. X is A, Y is B. Grid size is 20. C map is oranges, right? So it will give you a plot like this, right? Orange. So the darker the color, that means there are a very high more number of points, data points lie in this particular range. So it's like a scatter plot, but it is of the shape of a hexagons, right? And this size, I can change it to maybe 10. It will look like this. I can change it to 50. Sorry. If I do it maybe 50, it looks like this. See? So the grid size is the size, like so how many hexagons you want along the x-axis, how many hexagons you want along the y-axis, right? And if you can also pass a tuple. Suppose I want 10 by 20. So if I run this, I get a plot like this, because there are more number of hexagons along the y-axis and less number of hexagons along the z-axis. If you just pass one argument, it will adjust so that the hexagon looks more uh, regular, or not distorted, right? So you can pass the grid size. The last one is the kernel density estimation plots, or KDE plot. So it's very simple. You can just do any column plot KDE. It will give you a plot like this. So this plot gives you a normal approximation of the distribution. Okay. So if you want to see how your data is distributed as per a normal distribution sense of, then this KDE plot will give you the kernel estimation, density estimation, right? Or you can directly just use df2 plot density, then it will give you the density estimation of for all the columns A, B, C, D. You also get a legend over here, right? So this is what I have to discuss in this particular topics. It's very powerful that we can plot everything just using pandas without us having an additional requirement of knowing any other plotting library like matplotlib or seaborn. So guys, thanks a lot. I'll see you in the next lecture.